Now, if you've got a nitrate, it would also decompose to form a metal oxide plus NO2 gas would be produced plus O2 gas is going to be produced. Group 1 nitrates decompose differently. They produce nitrites, but remember group 1 is not in your course in AS or A2. But you did study this in O-levels. So for example, you've got a sodium nitrate, it would decompose to form a sodium nitrate. Plus oxygen would be given off. A metal reacting with water would produce like Na with water. And only very reactive metals react. So they're going to form a metal hydroxide or an oxide. So NaOH would be produced plus H2 gas would be given off. Then you had displacement reactions where a more reactive would displace a less reactive. So for example, you react Mg with copper sulfate. What's going to happen? According to the reactor series, Mg is more reactive. So it's going to form MgSO4 and Cu is going to be displaced. Similarly, hydroxides would decompose as well. Like you have magnesium hydroxide, you heat it strongly, it will turn back into its oxide and a water molecule is going to be produced. Okay, so remember all of these tiny reactions. Displacement, metal with water. The carbonate reactions are kind of more important. So it's 7 and 8 because that's in your, I mean, those are directly in your syllabus. So the carbonates and the nitrates decomposing, remember those equations, those are very important. And I'm going to talk about ionic precipitation just a little bit. So is this all clear? The last few reactions, is this clear?
Yes.
So now, okay, we can ignore ionic precipitation for now. We can do it some other time when we're doing group 2. So we can do that. And we can start with moles in this class. Okay, so let's start with moles. And let's cover the basics first. Okay, I'm assuming you know moles very well. And even if you don't, we'll be practicing a lot of questions. But my understanding is that most of you might know the basics very well. Like you would know what moles is, etc. So what's a mole? A mole, I mean, they're going to ask you for the definition for this. It's the amount of substance or not the amount, it's the number of particles equal to, so it's the number of particles. One second, it's okay. So it's the number of particles that's equal to the Avogadro's constant. So a mole is nothing but a unit for counting. Okay, you've got many units for counting, so mole is just another unit for counting. For example, you use dozens, you use hundreds, thousands, millions, billions, trillions. These are all units for counting. So 2 dozen is how much? That's 24. So this is the actual number. This is the same value in the unit. It's 2 dozen, that means 24. Now, why do you use units in the first place? Because it's easier. Like telling someone 1 billion is a lot easier. Your communication becomes easier. Instead of telling them it's 1 followed by, I think, 9 zeros. So these words are invented so that you can communicate easily. A trillion would have 12 zeros, a million would have 6 zeros, so and so on. But anyway, so these units are there, and the units keep changing as your quantity changes. Like you'll never count eggs in billions. Okay, some units are small, some units are big. So every quantity has its appropriate unit depending on the size. You don't count small things in thousands. I mean, although you can actually count them in thousands, but you won't, because that would be ridiculous, because it's going to give you values in decimals. So you use the appropriate unit for each counting, and that's what you do with moles. Moles is a huge number. That's 6.02 times 10 power 23. Now, the first thing is, if you want to convert something to a number, you multiply by the unit, which in this case is 12. If you want to go back and you convert it into units, you divide it by the unit, which is in this case 12. So that's our first formula. If I want to convert this quantity into the actual number, I'll multiply it by the unit. If I want to do the reverse, I'll divide it by the unit. For example, if I have this value and I want to convert that into thousands, how many thousands is this? So what I'm going to do is I'm going to divide this thing by 1000 by the unit, which is, so I'm going to divide it by 1000. That will give me 100. So this is 100,000. If I want to go back, I'll multiply it by 1000. So that's the same way with moles. So the first formula is that if you want to convert any number of particles into units, and remember, you can count anything using these units. So the number of particles would be divided by 6.02 times 10 power 23. That's what the unit is. And you'll find moles. So that's the first formula that you're going to do. Okay, is this formula clear?
Yes.
So now a few things. You can either use ratios. A lot of people use ratios as well. For example, what they do is that they say that 1 mole is 6.02 times 10 power 23 particles or atoms or molecules. You can count anything using moles. So you'll have, if you have 2.47 moles, what they'll do is they'll take ratios, do X, and then they'll cross multiply, and they'll be able to figure out that it's 2.47 multiplied by 6.02 times 10 power 23. Okay, and they'll find the value. Can you even tell me what the value is? Anyone, Mars, are you doing this?
Yes, 1.64948 multiplied by 10 to the raised power 24.
1.64
9
into 10 power
24.
24. Okay, whatever. I mean, you'll be counting atoms, molecules, etc. Okay, so that's one way. Now the thing is, you should be quick. Okay, remember, the first problem with AS moles is that you're always out of time. Okay, so using ratios, I mean, if you're very good at it, if you're really quick with it, keep using ratios. But if you're not, the faster method is the formula. And not even the formulas. What you should know is, I mean, you should practice it so much that it's instinctive. You don't even have to think about the formula. Like if you're given, if somebody's asking for the number of particles and you have moles, you multiply it by 6.02 times 10.23 without even thinking of the formula. If somebody gives you a number of particles and they're asking for moles, you divide by 6.02 times 10 power 23. So this should be automatic. You should be very quick with formulas. You should exactly know what has to be done. Take out your calculator, do it as quickly as possible. Okay. So you don't have time to think of ratios. You don't even have time to think about formulas. Okay. This should be instinctive. So the first thing that we're going to do is we're going to find moles, convert these values into moles. TK, everyone try and do this. So I've got 10 into 10 to the power 26 atoms of sodium. So how many moles is this? How many moles of atoms do I have? First one, did anyone try find the first one?
1,661.
So you're getting 1,000. You're getting for the first one, you're getting 1,600.
Yeah, 61.
That's for the first one. So that's basically what you did was 10 raised to power 10 power 26. And that was divided by the Avogadro's constant. Okay, now make sure you use your calculators properly. Put brackets around values. I mean, you have to clearly, calculators are really dumb. Okay, don't trust your calculators that much. Make sure you put brackets around your values so that you can clearly tell the calculator what's happening. So you get this one. What about the next one? How many moles is this?
1.865 into 10 raised to power minus 15.
Into 10 raised to power minus
15.
नहीं अब वही issue है कि this is what you're going to do. Okay, 11.23 into 10 raised to power 18. Okay, so to find moles, you divide by the Avogadro's constant, 6.02 times 10 power 23. So make sure you put brackets around it.
Yes, 1.865 into 10 raised to power minus 5.
Okay. Into 10 raised to power minus 5. Okay, that's your moles. What about the last one?
Zero point zero one three two.
0.01 कितना?
33.
As a 33 moles. So anyways, be very careful with your calculators. TK, it's they don't always work the way you want them to work. Make sure you tell them exactly what's going to happen. TK, put brackets. Start using brackets. TK, that's very important. Now over here, this should not be Ray. This is clear. Any issues? TK, this is Amna.
Yes, sir. Yes.
So this is simple. TK, just remember. You want to find moles of a substance and you're given the number of particles. Don't think of the formula. Don't think of ratios. Just simply divide by 6.02 times 10 power 23. Be very quick. Vice versa, if they're asking for the number of particles and you're given moles, you multiply by 6.02 times 10 power 23. And it should be instinctive. You should practice it so often that you don't even have to think. Don't waste time doing this. Don't waste time writing the formula. Remember, you're always running out of time. So I said, just hold on 1 minute. So now the next one. Now this thing is very important, and that is, if I try and find out the moles of this thing, let's say my desktop calculator is not really good, but let me try this. It's now this thing is very important. It's 8 and 10 power x. How do I write this? 8 exponent 21. Right? So I think that's fine. And I'm going to divide that by 6.02 exponent 23. And I'm using brackets. So I get this thing. So that's a now you round it off at this point. You started calling it 0.0133 moles, right? So it's a huge number. So what is the correct representation of this thing? Remember in O-levels you were told that you should write values up till the third significant figure, which should be this one. So following that rule, This is fine, 0.0133. But I'm going to be just a little bit clearer about the accuracy of the answers. Like, why don't we write 0.013289, or why don't we write 0.013 up till this point or this point, or why do we not stop here? So what's the correct way of writing this value and representing this value? TK. So remember, this is a small important point, and that is about significant figures. Like, how do you choose significant figures in the first place? And what is meant by significant figures? So can any one of you tell me what's the difference between this value, and this value? Anyone, any idea? Koi idea? What's the difference between these three values?
They are all same.
I said the value is the same. Okay, there's no doubt about it. They're exactly the same. But there's a huge difference. And that huge difference is the last one is more accurate. The first one is not accurate. Now remember, the value is exactly the same, except that the difference is in accuracy. The first one is accurate up to the first significant figure. The last one is accurate up to the fifth significant figure. Okay? So it has 5 significant figure accuracy. What does that mean? What it means is, like, what does it mean when I say that the first one is not accurate? What it means is, okay, we have no idea what comes after 2. It's a question mark. We don't have any idea what comes on the second decimal place, what comes at the third decimal place, or the fourth, or any decimal place after that. I just know the first one. I don't know whether it's 2.1 or whether it's 2.2, whether it's 2.01, or whether it's so this 2 has very bad accuracy. You have no idea what's coming after this. Is this point clear?
Yeah.
Okay. So the point is that when you just have 2 written, that means you have absolutely, I mean, you have got very little accuracy. What that means is this 2 could mean anything. Okay, this 2 could mean 2.01. It could mean 2.20 or 22. Okay, we have no idea because we don't know anything about this. Okay. I said, what about this one? Why is this accurate? The reason it's accurate is because I'm pretty sure that the first decimal place, second, third, fourth, I know all of them. They're all 0. What I don't know is the 6th significant figure. I don't know what comes after that. I don't know what comes after that. So my accuracy, this one is way more accurate. I'm pretty sure up till this point that it's 2.000, and this one is also 0. This one has an accuracy up till the 3rd significant figure. After that, I'm not sure what comes after that. Is it 2.001 or is it 2.009? Whatever, I'm not sure. Okay. So is this point clear? What was the difference between the 3 values? Okay, is this clear to everyone?
Yes.
Okay, so first thing, significant figures, they represent the accuracy. And they represent the accuracy of the device that you're using. Okay? For example, you stand on a weighing machine. Okay? I stand on a weighing machine, and that gives me that tells me that I'm 94 kg, right? And so that's accurate up till 2 significant figures. Okay? The display on the machine has no other number. It doesn't tell me what is coming after that. The machine has no idea. It just has 2 numbers on it. I stand on another weighing machine, and that tells me that my weight is 94.12 kg. So that's way more accurate. That's accurate up till the 4th significant figure. The 1st, 2nd, 3rd, and 4th. So it gives me 4 numbers. So a lot more accurate. This one is a lot more accurate. And there might be another machine that would be even more accurate. So all of these are measurement values. You're measuring mass, you're measuring volume, you're measuring length. Okay? So you're measuring a lot of things. So every device has a certain accuracy and they represent accuracy. Now moving on to this, moving on from this. Reid, is this clear? Ospa, is this clear?
Yes, sir.
So now moving on from this, what do we do with significant figures? So let's say I'm trying to measure the area of a page, and I just have to do length into breadth, right? Or length into width. Okay, so I just need to multiply these two values. I take a piece of paper, and I've got different devices that can measure length. Some are less accurate, some are more accurate. So for example, I've got one that measures the length as 10.12 centimeters, right? Just 1 second. So it gives me 10.12 centimeters. And then I take a less accurate device and I measure the width with that, and that gives me 4 centimeters. That's it. Nothing. It didn't even tell me whether it's 4.1 or 4.2 or what. It just told me just one number, that's 4. It just had one number on its display and just gave me one number, that's 4 centimeters, right? So I need to find the area now. So it's going to be the length, which is 10.12 multiplied by the width, which is 4. So that would give me what? 10.12 multiplied by 4. What is that? 10.12. That's 100.12. Just a second. So it's 10.12, and I'm going to multiply that by 4. And I get 40.48 as my answer. Centimeters square. Now the problem is, one of my values was accurate up till 4 significant figures, and one of my values was accurate up till 1 significant figures. Now, because this, now listen to this point very carefully. A lot of times you'll face this problem, and that is that one value would be more accurate, and the value that's coming from the other device is less accurate. So how accurate is your answer now? Because of this one, the problem is you're not sure what's coming after 4. You just know the first significant figure. So you're very sure about the first significant figure. So that creates doubt in the second and the third and the fourth. Like I don't know what the second one is. I don't know what the third one is. I don't know what the fourth significant figure is. So that kind of creates doubt in all the other significant figure places. So these 3 numbers are now doubtful. Are you getting my point? Is this point clear? Sidra, Raid, is this clear? Maz, Ahmed? Can you guys hear me? Amna, is this clear? Just a second.
So your voice is lagging actually.
I'm so sorry. Is it better now?
Yes, sir.
So my point was that I'm going to repeat the point. So one of the value is accurate up till 4 significant figures. And this other value is accurate up till the first significant figure only, because I don't know what comes after 4. I don't know what the other numbers are after 4. So it's accurate up till the first significant figure only. So the problem is that if I do a calculation using both of them, only the first significant figure we're sure of. Because of this number, all the other numbers are doubtful. So this one has a question mark now. This one has a question mark. This one has a question mark. So my value would be accurate up till 1 significant figure only. So I'm going to just round it off till the first one. That's it. I'm not even going to write the decimals because that has lost all accuracy. My answer would be accurate up till 1 significant figure. So let me repeat this point. I got two values. One of them was way more accurate. The other one had terrible accuracy. Because of this value, all the other significant figures are now doubtful. Okay, because we don't know what they are. I mean, because I'm not sure is it only 4 or is it 4.0 or is it 4.1? I'm not sure about these other numbers. So that creates doubts in all these other significant figures. You're only sure about the first one. So is this point clear? Is this clear or no? Yes or no?
Yes.
So is the voice still lagging?
Yes, sir.
Just a second. Let me. Is it better now?
Yes, sir, it's better.
It's okay. The only thing was that answers are only accurate up to the least significant figure value. Okay, so they are accurate up to the I think there's an issue with the internet. I don't know why. The least significant figure value. So is this clear? This last thing.
Yes, sir, it's clear.
Achha, so remember, okay, a lot of times what will happen is that you'll be doing you'll be doing different formulas, right? And you'll be using different values. For example, sometimes they might ask you to find the moles, or we'll do these formulas later. Let's say concentration times volume, and the concentration is given like this, 0.120 mole per dm cube, right? And the volume that they've given is it just says 12 cm cube. So if you use the formula and you multiply concentration with volume, 0.120 multiplied by 12 divided by 1000, what's going to happen is that one of the values is accurate up till two significant figures, because you're not sure after what comes after 12. You're not sure about that. And the other value is accurate up till three significant figures. So your answer will have an accuracy up till the least significant figure. That's two significant figures. So can anyone tell me what is the value that you're getting for this? What's 0.120 multiplied by 12 multiplied by 12, and then I want to divide that by 1000.
1.44 multiplied by 10 to the raised power minus 3.
So you're getting 0.00144, okay? So that's the value that you're getting, 0.00144 moles. So you're getting 0.00144 moles. But since one of the value was accurate up till two significant figures, that would indicate that your answer cannot be more accurate than that. Okay, it can't be more accurate than the original value. So you would have to round it off till two significant figures. So it's going to be 0.0014, round it off at the second. You'll just call it 0.0014 moles, not 44. Is this clear?
Yes.
चलिए Sidra, is this clear? Oswa, Reed, is this clear?
Yes.
Achha, so we're going to do the other moles formulas now. We did one of them. The other ones are moles is equal to mass over AR MR, AR or MR. That is moles. Okay, you have done this formula as well. So what this formula is that it's simply a conversion of a ratio. Like the mass of 1 mole of a substance is given in the pure table. That's your molar mass. So it's your AR or MR that's given in the pure table that's expressed in grams. So it's simple that somebody has calculated and given you values of 1 mole of substances. For example, 1 mole of sodium atoms. In the pure table is 23. Is my voice still lagging?
Yes, a little bit.
So, okay. I think I haven't paid the bill. Just a second. It's क्या data?
Yes, sir.
Yes, sir.
Achha, your voice is lagging as well. So what we can do is we can continue tomorrow. I'll check the internet. It was working fine. It usually is working fine. Maybe I'll check the bill. Okay. So I'll just go through this formula very quickly. So the mass of 1 mole of a substance is given in the pure table, and so you can use ratios. Like if you have 10 moles of sodium atoms. नहीं बल्कि my board is hanging as well. We can continue tomorrow, okay? We'll continue tomorrow. I'll just sort out the internet issue, okay? No, it's gone. So let's continue tomorrow, okay? Hopefully by then I'll sort out this issue.
Okay, sir.
Okay, everyone, take care.
Okay, sir. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.